Alrighty, these are notes for Unit 2 for Course Support Math. Make sure you put your first and last name, always. This will be third period, but it could be with period. They're the same. All right, let's get started. So a ratio is an association between two or more quantities, meaning two or more things. There's a couple ways that we describe a ratio situation, and we can look at this as an example. The ratio of squares to circles. So we count how many total squares, because squares is first. We put the square number first. 1, 2, 3, 4, 5, 6. The second word is circles, so that would be the second number, 1, 2, 3. We could also change the order, and if we say circles first, then the 3 has to be first, and then squares is second, so the 6 would have to be second. And then we want you to notice that you can make equal size groups. So from our original 6 to 3, we've now made 3 groups. So we can say in each group there are 2 squares for every 1 circle. And we can see that right here. Or we could change the order. There's 1 circle for every 2 squares. So we're going to do our vocab. A ratio is an association between 2 or more quantities. Quantities is something that can be counted. You can think of it as things, objects, items, similar ways of saying that word, but things that can be counted. All right, if there is a basket of fruit, there's 9 bananas, 4 apples, and 3 plums. Go ahead and write the ratio for each of those. The first one is bananas to apples. So that would be 9 to 4. And you notice we can use colons for a ratio. The second one says plums to apples, so plums would have to go first. Go ahead and write it. That would be 3, and the apples are 4. Using the word to is another way to write ratios. So we have a colon, we have the word to, and for every blank apples, so we can say for every 4 apples, there are blank plums. We can also write a ratio as a fraction. So this could be 4 to 3, 4 to 3, or 4 to 3. For every 3 bananas. Now, if you look right here, there's 9 bananas. So if I have banana, 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 banana. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we're talking about 3, that means group of 3, group of 3, group of 3. So then we need to look at our apples and our plums. Could apples be broken into 3 equal-sized groups? Not really, but plums could. If I have plum, 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 we can make 3 groups of plums. So for every 3 bananas, there is 1 plum. All right, on the last part, we have to practice writing that ratio sentence. You have to use these ratio sentences on your test. You have to be able to write 2. So all of these right here are an example of a correct ratio sentence. So I will write a couple of them. So let's see, how many eyes do we have? I can say there's 2 eyes on this guy, 2 eyes on this guy. So I'm going to say there's 4 eyes, there's 4 legs and 4 legs, and there's 8 legs. So I could say the ratio of eyes to legs is 4 to 8. I'm going to do it for every 8 legs. I'm going to do legs first. 8 legs. There are eyes. I could also break up my groups. If I have 8 and 4, I could also think of that as 2 to 4. I could think of it as 1 to 2. I could say for every 2 eyes, there are 4 legs. And you can notice that right there. He has 2 eyes, he has 4 legs. He has 2 eyes, he has 4 legs. So those are examples of how to write the correct ratio sentence. Write one more ratio sentence. Pause the video. All right, we'll go to the next page. Representing ratios with diagrams. So we had a little bit of diagram on the other side. This we would consider like a picture or a display. This would be considered a diagram. So we're using squares or circles or something simple to describe our ratio so you don't have to make a really detailed picture. So for example, this says 2 scoops of lemonade powder, 6 cups of water. So these would be our scoops, and the large cups would be your cups. Now this right here could represent this. This would be my scoop, the little ones, and then the big ones would be the water. And you can still see it's a 2 to 6. The diagram shows a ratio of cups of water to scoops of lemonade is 1, 2, 3, 4, 5, 6. Water is first, so 6 to 2. We can also see that for every scoop, meaning every 1 scoop, which means I broke this into a group where there's only 1 scoop, there are 1, 2, 3 cups of water. So we would call that an equivalent ratio because we have a 6 to 2, or we have a 1 to 3. And hopefully you notice that there's some sort of pattern with these numbers, right? It looks like this is half of the first one, and you can notice if you cut the group into 2 pieces, you have half of the group. All right, let's do some practice. Here's a diagram that describes cups of green paint and cups of white paint. Select all. All means there's always more than one correct answer. So first thing it says, the ratio of cups of white paint to green paint. Well, it looks like white, I have 2. White is first. Green, I have 4. They're saying it's 2 to 4, so I agree. For every cup of green paint, there are 2 cups of white paint. Now this brings up something important. When you see the word every, you would think of the word each, sorry, I wrote that kind of wacky, and also the word per. These all mean 1 when we're talking about them in a sentence. So this would say every cup of green paint, so 1 cup of green paint, there are 2 cups of white. So let's look. If I just have 1 cup of green paint, are there 2 cups of white? No, that is not a true statement. The next one says the ratio of green to white. Green is 1, 2, 3, 4, and white is 2. So that is a true statement. For every cup of white paint, every meaning 1, so there's my 1 white paint, there are 2 green. Now that I would agree with. The ratio of green to white. So green is 4. So green's the first word. The first number should be 4. That is incorrect. To make a snack mix, combine 2 cups of raisins with 4 cups of pretzels and 6 almonds. We're going to draw a diagram. So raisins, I could just use letters, but I'm going to do squares are raisins. I'm going to do triangles are pretzels and circles are almonds. So then I need 4 triangles. 1, 2, 3, 4, and then I need 6 almonds. 1, 2, 3, 4, 5, 6. So that's a 2 to 4 to 6 ratio. Could I also do half of this? I could. That would be a 1 to 2 to 3 ratio because I cut it in half. Uh-oh, sorry. So I cut that in half. And hopefully you notice to go from 2 to 1, 4 to 2, and 6 to 3, when we say cut in half, it's the same as dividing by 2. All right, turn the page when you're ready. All right, lesson 4, 3 and 4 were kind of smushing together. When mixing colors, we can double or triple the amount of each color. So when I say double means I'm multiplying by 2. If I say triple, what do you think I'm multiplying by? Well, a good guess would be multiplying by 3. So, in fact, we can always multiply the amount of each color by the same number. And it's really important that we do that, by the same number. For example, to make a batch of dark orange paint, we have 4 milliliters of red and 2 of yellow. So if we look right here, here's our original recipe. 1, 2, 3, 4 of red and 2 of yellow to make our orange paint. Now, if we want to double that, that means I need 2 groups of this, which is where they're showing here. I would have 1, 2, 3, 4, 5, 6, 7, 8 in my 2 batches, and I'd have 4 yellows in my 2 batches. And then when we triple it, we need 3 sets of the same answer, which is the same as multiplying by 3. So to make 2 batches, we would have 8. So you can see that 4 has been doubled to an 8. And then we need 4 yellow. You can see that's been doubled. To make 3 batches, we end up with 12. So that would be 4 times 3 equals 12. And our yellow ends up to be 6, and you should notice that's 2 times 3 equals 6. So up here when they said multiply by the same number, both of these were multiplied by 3. We say the ratios, 4 to 2, 8 to 4, and 12 to 6. So this one was 4 to 2. This is 8 to 4 because there's 4 white, and this is 12 red to 2, 4, 6 yellow. They're all equivalent ratios because they describe the same color, but we have different numbers of batches. They make the same shade of orange. So if you have equivalent ratio, it's going to be exactly the same, you just have more of it. When doubling a recipe, how does the amount of each individual ingredient changes? So each ingredient is multiplied by 2 because that's what doubling means. All right, here's some practice. Lesson 3. A recipe for 1 batch of spice mix says 3 teaspoons of mustard seeds, 5 chili powder, and 1 salt. So let's find that in our picture. There's my 3. There's my 1, 2, 3, 4, 5. And there's my 1. So it says how many batches. So we're going to group it by this recipe. 3, 5, 1. 1, 2, 3, 1, 2, 3, 4, 5. And there's my 1. 1, 2, 3, 1, 2, 3, 4, 5. And there's my 1. 1, 2, 3, 1, 2, 3, 4, 5. So how many total batches did they make? They made 3 batches. So you could tell that 3 times 3 is 9, 5 times 3 gives us 15, and 1 times 3 gives us 3. We'll just even write that. 3 times 3 equals 9. I don't know why I wrote that. 3 groups of 5. 3 times 5 is 15. And the last one, 3 times 1 is 3 for our 3 batches. Diego makes green paint. He uses 10 tablespoons of yellow, 2 tablespoons of blue. Which mixture would be the same shade of green? And it's an all. So I'm going to just do my thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have my diagram, and then I need 2 blue. I'll just do a little square for my blue. For every 5 blue, there's 1 yellow. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5. And I should even write this. This is yellow. This is blue. So I would agree. That's a true statement. Mix blue paint and yellow is 1 to 5. So you look at blue first. Blue is 1. Yellow is 5. So that is a true statement. Mix yellow and blue. So yellow is first. And they're saying 15. That's 5. That's 10. So let's say I had 5 more. 1, 2, 3, 4, 5. And then I have 1 more blue. So that would be 5, 10, 15 yellow. 1, 2, 3 blue. So that would still be a true statement. 11 yellow and 3 blue. Well, I have my 3 blue, but it's not 11 yellow. It's truly 15. So that is incorrect. All right, turn the page when you're ready. Remember to stop the video anytime you need, so you stay caught up. Lesson 5. All ratios are equivalent to AB. Alrighty, lesson 5. All ratios are equivalent to AB can be made by multiplying both A and B by the same number. And when we talk about the same number, a lot of times I'm going to call that a factor, because factor is a number that we multiply. Sometimes we might call it a multiplier. I'm really going to try to say the word factor. So, for example, this is what we're talking about. If I have the ratio 18 to 12, I can prove it's equivalent to 9 to 6. Now, some of you might just recognize those numbers. You might be like, oh, if I double 9, I get 18. If I double 6, I get a 12. So that means they are both being multiplied by the same number, which is 2, right? 2 is when you double. Multiplied by 2 is a double. So 6 times 2 is 12. 9 times 2 is 18. So we know that they're equivalent. We can also make something smaller by being multiplied by the same number. Now this time it's multiplied by 1/3. When you multiply something by a third, it means you're breaking it into 3 equal sized pieces. So I know that 6 is the same as 2 plus 2 plus 2. So a third of that would be 2. And a third of 9 is 3. So I'm taking 9 and dividing it by 3. So those are still equivalent. Now we can look, is 18 to 15. That ratio equivalent to 9 to 6. Well, look, 9 times 2 is 18, but there's nothing, or I shouldn't say nothing. The thing you try is the 2. What is 6 times 2? 6 times 2 is 12. It is certainly not 15, so it is not an equivalent ratio. So the answer is no, because 9 times 2 is 18, but 6 times 2 is not 15. Let's make another equivalent ratio, 9 to 6. 9 to 6. I can choose any factor that I want to multiply. I can use 4. So if I times this side by 4, then I times this side by 4. And you can still use your calculators in this unit. So it would be 6 times 4 is 24, which means to stay equivalent, I would also have to do 9 times 4. So that would be 36. All right. So vocab, equivalent ratios. Two ratios are equivalent when you can multiply each of the numbers in the first ratio by the same number to get the numbers in the second ratio. And when I say number, I'm going to say the same factor, because factor is a number we multiply. All right, here's some practice problems. I want you to practice, try to do them first before you see the answer, so you can stop the video. Show why these are not equivalent. So one way to show is to stack them. I like the stacking method because it's easy to look at. Now, you can look at this and think, well, that's kind of wacky. And I'm hoping you notice that. That's another reason why it's really important to know your multiplication facts, because you can notice these things right away. Right away, I know that 4 times 2 is 8. So then I want to try 6 times 2. Does 6 times 2 equal 18? No. So not equivalent. Now, I could have approached it from the other direction. I could have said, I know 6 times 3 is 18, but 4 times 3 is not 8, so it's still not equivalent. And then we'll do the same with this. Remember to stack it because it's easier to compare. And think of whichever direction you want to go. I could say this way, I know that half of 6 is 3. Is 6 half of 3? No, I know the answer is no, but if you're not sure, try it with me. So you take the number 3 times 1/2, and we'll do the same over here. 6 times 1/2. Now when we multiply fractions, you have to make that whole number 3 look like a fraction, so we put a 1 under it. And we'll do this side first. 6 times 1 is 6. 1 times 2 is 12. Is 6 half of 12? Yeah, it simplifies to 1/2. 3 times 1 is 3. 1 times 2 is 2. Is 3 half of 2? No, it's not. So these are not equivalent. And some of you will be like, well, if you change the order, then it's still wrong, because the thing about ratios is you cannot change the order. So when we were talking about the words and the numbers matching, they have to match correctly. You can't change the order. All right, lesson 6. This is going to get you to the quiz. I think lesson 5 gets you to the quiz. So if you can understand everything on the first 5 lessons, you should do great on the quiz. Lesson 6, you can use a double number line. So it's a new type of diagram to show equivalent ratios. For example, in the juice for fizzy juice recipe, mix 5 cups of cranberry juice and 2 cups of soda water. So I can see that right here. One thing, you always have to have labels. You always have to start with your 0 And then you need to make sure you're counting equally. So here's my 5 to 2. The ratio of cranberry juice to soda is 5 to 2. And then you notice cranberry is going to count by fives. 5, 10, 15, 20, 25. Because 5 to 10, that would be my double times 2. To 15 would be my triple times 3. To get to 20 cups of juice, that means I would make 4 recipes or times 4. And to get to 25, I would make 5 recipes. Okay. The same with the soda water. It's counting by twos. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So it is showing the ratio of 20 to 8 is equivalent to 5 to 2. And so a lot of times I'll do this. How many 5s does it take me to get to 20? Well, it's times 4. How many 2s does it take me to get to 8? It's times 4. So you notice we have the same factor. We have a factor of 4, which means we made 4 batches of the recipe. And what do you think? Are they going to taste the same or are they going to taste different? They're going to taste the same because our ratios are equivalent. Equivalent, which is a fancy way of saying equal. Hopefully you notice that. All right, so if you mix 20 cups of cranberry juice with 8 cups of soda, it makes 4 times as much juice, right? Because we multiplied by 4. That tastes the same as the original recipe. The top line number counts by 5s. The bottom number counts by 2s. And a new vocab term. Let's see. Double number lines diagram. It uses a pair of parallel number lines to represent equivalent ratios. The location of the tick marks, if you're not sure what tick marks are, that's these little guys, match on both number lines. The tick marks labeled 0 always have to line up, but the other numbers are usually different. I'm going to stop the video right here. Okay, so the next question, why might we use a double number line instead of a picture? Pictures work great when you have like 4 to 2. But once we got up here and we had like 20 and 8, I don't necessarily want to draw that many pictures. What if I had 20 by 8 and I wanted that to be doubled? I wouldn't want to draw 40 items, but I can quickly use my number line. I can say this is my juice, this is my water. I can say this is 20, this is 8. If I double that, then I know that's 20 times 2 is 40, 8 times 2 is 16. So a double number line is a lot easier to use when the numbers get larger. Okay. And then the practice. We have a double number line showing flour and eggs. Here's my flour, here's my eggs for 1 batch of cookies. So sometimes I like to just write on there, this is 1 batch. I need to show how much for 2, 3, and 4. So 2 batches is a double. So that's times 2, times 2. 5 times 2 is 10. 3 times 2 is 6. It's also the same as skip counting. 5 times 3 is 15. 3 times 3 is 9. 5 times 4 is 20. 3 times 4 is 12. I can write that times 3. Oops, sorry. Times 3. And all the way over here is times 4. So this is my second batch. This is my third batch, and this is my fourth batch. What is the ratio of flour to eggs? Well, the original ratio is 5 to 3. How much flour and eggs are in 4 batches? So I look at my table. 4 batches is 20 flour, 12 eggs. So I use my double number line to answer my questions. How much flour is used with 6 eggs? So if I find my 6, that's 10 flour. And how many eggs are used with 15 flour? 15 flour, 9 eggs. All right, I'm going to stop right there.